Okay, multiplying and dividing real numbers. This is actually the 8th movie in our Algebra Foundation series, and this is actually more simple than subtraction and addition with real numbers, and here's why. Typically, we think about 3 times 2 equals 6. Pretty straightforward. If we put a negative in here, just one, either -3 or -2, they both result in -6. So one of the two numbers being negative will produce a negative product. Neither of the numbers being negative obviously produces a positive product. And then the fourth scenario is just like the first. If both numbers are negative, then we have a positive product again. Well, what if there are three numbers? 3 times 2 times 3. Well, if any one of the numbers is negative, then you have a negative product. So here we have a positive product, 18. If we have a -3, then we have a -18. If we have two negative numbers, let's say both the 3 and the 2 are negative, then we would go back to a positive. But if all three numbers are negative, then it would be negative. And the pattern is actually this. It can be thought about this way. If you have an even number of negative signs, you're going to have a positive number. If you have an odd number of negative signs, you're going to have a negative number. So if you think about it like positive, 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 positive. If it goes to negative and never switches back with another negative sign, it's going to be negative. If it goes negative and then we have another negative, that means positive and stays positive, then it's going to be positive. If it goes negative and then becomes positive and then becomes negative again, it's going to be negative. So an odd number of negatives produces a negative product. An even number of negatives produces a positive product. The same thing can be said for division. It actually works with exactly the same rules. So for example, if you have 6 divided by 3, and in fact in algebra we're not going to be writing it this way very often. We're actually going to be writing it more often in fraction form. 6 divided by 3. If we have 6 divided by 3, that equals a positive 2. Likewise, 6 divided by 3 equals a positive 2. If either one of those numbers is negative, so if it's -6 over 3 or 6 over -3, those are both going to equal a -2. And just like multiplication, if both are negative, it's going to result in a positive 2 again. And the same rule applies. If there's an odd number of negatives in the expression or in the term, you're going to have a negative result. If there's an even number of negatives, 2 or 0 or 4, it's going to be a positive result. I want to refresh us, though, on not just multiplying and dividing negative numbers, but actually multiplying and dividing real numbers. Let's look at fractions for a moment. If I have 1/3 times 2/5, I do this by actually doing multiplication across the top. To solve this problem, you're actually going to do multiplication across the top and multiplication across the bottom. So we could rewrite this problem as 1 times 2, 3 times 5. 1 times 2, of course, results in 2. 3 times 5, of course, results in 15. Division is a little bit different. Instead of dividing across the top, dividing across the bottom, what we really want to do is rewrite this as a multiplication problem. And to do that, we're going to need to use the reciprocal of this second fraction. So 1/3 divided by 2/5 can be rewritten as 1/3, and we use the reciprocal times 5/2. And then we continue along just like we would with any multiplication of fractions. 1 times 5, 3 times 2, 5/6. So 1/3 divided by 2/5 is 5/6. So this is how we multiply fractions. This is how we divide fractions. And we are going to write them in this way. And that goes for algebraic expressions and terms as well. right? We could just as easily have 2x over 5 times 3 over 7, which would result in 3 times 2x on top and 5 times 7 on the bottom, or 6x over 35. And it'll work the same way with algebraic terms and expressions, but the math holds. This is how you multiply and divide fractions. Real numbers include decimals as well, so we also want to know how to deal with decimals. Decimals really aren't different than multiplying and dividing larger whole numbers, especially when it comes to multiplication. So if we have 3.2 times 4, we don't have to worry about lining up decimal plates. There's one there. Technically, there's a decimal place here and zeros after it. We don't have to worry about lining any of that up. That's addition and subtraction. With multiplication, this is just like two-digit multiplication. 4 times 2 is 8. 4 times 3 is 12. We have one decimal place currently in the problem, so we move one space over and we put our decimal place right there, so the answer is 12.8. Everything in a multiplication problem is what we call right justified, meaning everything is shifted all the way over to the right side no matter how long it is. So even if we have 4.22 and 376, even though these are of much different magnitudes, they all line up right over here and then one number under the next until we run out of numbers. You do generally want the longer number on top. It'll make the multiplication easier, but they're always right justified, meaning they always push up against this line when doing that problem. Dividing decimals is the only place where it gets a little bit different. So if we have 3.2 into 0.64, we don't really want to have a decimal place out here, so instead of 3 2/10, we move the decimal place over once, making it a full 32. But if we do that, we also have to move the decimal place in the dividend. So if we're going to move it in the divisor, this is the divisor, we have to also move it in the dividend. So if we moved it one place here, we have to move it one place here. So we end up with 32 into 6.4. And we say, okay, 32 goes into 64 twice. And wherever the decimal point is here underneath the line, it goes right there above the line. So the answer to this problem is 2/10. It goes in 2/10. 32 goes in 2/10 of a time to 6.4. Or another way of thinking about it is 6.4 goes into 32. 32 goes into 6.4, 2/10 of times, or 2/10 times 32 is 6.4.